Have you ever built a robot, hit the start button, and nothing worked the way you expected? Welcome to the club. Every robotics engineer on the planet has been exactly where you are right now. The good news? That's not failure. That's the beginning of real engineering. This is where prototyping and testing come in, the secret weapons that turn wild ideas into working robots. Think of prototyping as building rough drafts of your robot, and testing as the detective work that reveals what's working and what needs fixing. Here's something that might surprise you. Professional engineers and robotics companies never expect their first version to work perfectly. They build prototypes specifically to fail, learn, and improve. It's like writing a rough draft of an essay. You don't expect it to be perfect, but it gets your ideas on paper so you can make them better. The smart approach to prototyping starts simple. Before you break out the expensive motors and sensors, grab some cardboard, popsicle sticks, or even Lego blocks. Build a basic model to test your robot's overall size, shape, and movement. Many championship robotics teams start with paper sketches and cardboard models before they touch a single electronic component. Why? Because it's way easier to fix a cardboard prototype than to rebuild a robot that's already wired and programmed. It's like tweaking a recipe before you bake the whole cake, much cheaper and less frustrating to get it right early. Once your simple prototype shows promise, then you level up to functional prototypes using the actual components. The key is taking small steps from simple to complex so you can pinpoint exactly where problems occur. Now, let's talk about testing, and this is where you become a robot detective. The best testing follows one golden rule: change one thing at a time. If you're testing your robot's ability to detect objects, first test just the sensors in different lighting conditions without worrying about the movement parts. Keep detailed records of your tests. Create a simple testing log where you write down what you tested, what happened, and what you want to try next. For example, test line detection in low light. Result: sensor failed to follow line. Change added LED under robot. Here's the mindset shift that separates real engineers from frustrated builders. When tests reveal problems, get excited. These aren't failures, they're valuable discoveries that make your robot better. Every problem you find during testing is a problem you won't have during the competition. The cycle of prototyping, testing, and improving might repeat many times before you reach your final design. And that's perfectly normal. Each cycle gets you closer to a robot that works reliably. Remember, every incredible robot you've ever seen, from Mars rovers to championship competition bots, went through dozens of prototypes and hundreds of tests before they became amazing. The engineers who built them didn't have magical powers. They just embraced the process of building, testing, learning, and improving. Every time you build a prototype, run a test, and make an improvement, you're thinking like a real engineer. You're not just hoping your robot will work. You're systematically making sure it will work. So the next time your robot doesn't work on the first try, smile and say, "Perfect! Now I have something to improve." Because that's exactly how the best robots in the world were built. Every time you build a prototype, run a test, and make an improvement, you're thinking like a real engineer. You're not just hoping your robot will work. You're systematically making sure it will work.